Wow, Alexa, this looks just like a papier-mâché volcano a middle schooler would make for a science fair. What's going on here?
Well, it is a papier-mâché volcano. Research geologists, we love our papier-mâché volcanoes just like anybody else. So the reason we have this is that it's a very simple scaled replica of Mount St. Helens, but really what's underneath is what's interesting, because this is a little demonstration that we use to show how volcanic plumes rise up into the atmosphere. So, for example, we're really interested in how fast volcanic plumes rise, how they widen as they extend up into jet airspace, and we're really interested in turbulence. So that's how these eddies entrain air as the ash plume is rising up through the atmosphere. So we do laboratory experiments and numerical simulations using computers to study how that works.
Alexa, why is it important for aircraft to know about this plume?
Well, volcanic ash is dangerous to jet engines. And so we really want to be able to keep aircraft safe out of the way of volcanic eruption plumes. But if we really want to look at that, we should look at some volcanic ash under the microscope in the lab.
Oh, that'd be cool.
Let's go.
Let's go.
Okay. Here we are in the lab. Now, I've got a sample for you. What do you think this is?
Salt and pepper.
Yeah, it looks like just like salt and pepper.
Metal shavings.
This is volcanic ash. So you were asking about volcanic ash and why it's hazardous for jet aircraft. Well, this is what we can look at. Volcanic ash is different from the ash you see in wildfires. It's different from smoke because that's made out of burnt up plant material. That's not in volcanic ash. Volcanic ash, well, you tell me actually, Marty, put it under the microscope there. What do you see?
Oh wow, it's like sparkly and it almost looks bubbly. That is cool.
Yeah.
And it's white and black and all kinds of different shades.
Right. So what you're seeing there are all pulverized pieces of magma. So it's all volcanic rock. So that's what volcanic ash is. It's pulverized rock that originated from the magma deep under the volcano.
And what does it do to jet engines?
So the reason this is unsafe for jet engines is that the volcanic glass melts. It has a low melting temperature. And when glass melts inside an engine, it can make the engine overheat and it can be really unsafe for the people inside the airplane.
But when a volcano goes off, that's a big event and everybody knows about it. Why can't they just fly the airplanes around it?
Well, there are actually eruptions happening every single day. So we don't always know every single eruption that's happening around the world. There are more than 1,500 volcanoes on the planet that are active at any given time. And so there can be multiple eruptions happening during the day that we might not necessarily know about. That's why it's so important to coordinate with atmospheric scientists and volcano scientists so that we can have a better picture of how to reroute aircraft.
Now, the Mount St. Helens explosion looked a lot different than the one that recently happened in Hawaii. Why is that?
Okay, to answer that question, we should really look at the rocks. So here's a good example. Okay, so this is volcanic ash from the 1980 eruption of Mount St. Helens. And you can see that it's tiny particles of volcanic ash. So that eruption was so explosive that it blew apart the magma into tiny, tiny pieces. It was really full of gas because gas is what drives the explosiveness of an eruption. Now, at Kilauea in Hawaii, which erupted so recently, there's not as much gas in the magma. And so that story is recorded in the rocks. And we can look at that here. So these are volcanic rocks. So these are actually called golden pumice from Kilauea during the 2018 eruption. And this is very different from the volcanic ash we just looked at. See, hold this in your hand.
That's not a rock, that's styrofoam, right?
This is a real rock.
It's so light.
It's so light because it's mostly made out of bubbles. And these rocks came from the really high lava fountain from Fissure 8 at Hawaii in 2018. And this is important because it's really the bubbles inside the rocks that tell the story. So even though there was clearly some gas in the eruption, because we see all the bubbles, that's the gas that was left behind, it wasn't gassy enough to blow itself apart into tiny pieces of volcanic ash like Mount St. Helens.
So even though this looks like it's got all these bubbles and gaps and spaces in it, the ash actually shows us that there was more gas in it because it blew it apart.
Because it blew it apart, whereas these are bigger chunks. It didn't blow itself apart quite so effectively.
If you just saw that or picked that up, you would think it was a piece of styrofoam.
I know.
And this is really how we do geology. We use these samples that we collect from the layers in the geologic record to tell the story of what happened during the eruption that made them.
So you're a rock storyteller.
They're like books to geologists.